We've always been fascinated by the question, what's out there? Since the dawn of man, people have looked at the stars in the night sky in wonderment and awe. Does someone else in our universe, or even in our own galaxy, do the same? Astronomy has always speculated about life elsewhere. It was believed that life may exist on the moon, and after that, Mars. Nowadays, some people believe life may exist under Jupiter's moon Titan's icy surface, in an ocean of water. Although we don't have proof of this, there's a push to send a probe to go under the surface and search for life. The implications the discovery of life would have on science are enormous. We do not know if life elsewhere is common or rare, although most scientists would agree that there is life somewhere out there. We may or may not find it. Arthur C. Clarke once said, "Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying." When NASA launched Pioneer 10 and 11, they added a plaque to them in case they are ever received by extraterrestrials. On the plaque is a map of the solar system, a map of the probe's origin, and a nude male and female human figure. Voyager 1 and 2 were each equipped with a golden record in case they were ever intercepted by intelligent life. The records contain pictures and audio that show a diverse collection of life and cultures on Earth. Although both of the probes are minuscule compared to the vast emptiness of space, and that makes the chances of anyone finding them slim, it says a lot about how we believe something could be out there. All four probes are on escape trajectories outside of the solar system and into interstellar space. In 40,000 years, Voyager 1 will be 1.6 light years away from the star Gliese 445. Some theories exist about how common life in the universe is. The most famous is probably the Drake equation. This equation estimates how many active communicating civilizations currently exist in the Milky Way galaxy. The first variable is the number of new stars that appear in the galaxy every year. The second is the fraction of stars that have planetary systems. The third is the fraction of those planets that could potentially support life. The fourth is the fraction of those planets that could actually develop life. The fifth is the fraction of those planets that develop intelligent life. The sixth is the fraction of those planets that develop civilizations with technology to send detectable signals into space. Finally, the seventh is the number of years that those civilizations exist before they are destroyed or go extinct. This equation is only a guess at how many civilizations are in our galaxy, and since the only life we know is on Earth, it is hard to assign some of the probabilities. A pessimist estimation would be 0 or close to 0 because of the very low assigned probabilities. A compromise, or a guess with decent probabilities, would be 3,500 civilizations in the Milky Way galaxy. However, an optimistic estimation would put billions of other civilizations alongside of us in our galaxy. There are people on the other side of the spectrum who believe intelligent life is rare, or it doesn't exist. People with this belief use the Fermi paradox as an argument. The Fermi paradox states that if the Drake equation was true, then Earth should already have been visited, either in the distant past or now. It also states that there is still zero evidence that life exists outside of Earth. The Fermi paradox can be simplified to this: where is everybody? Until concrete evidence of extraterrestrial life is found, the Fermi paradox will continue to be a valid argument for those who oppose the notion that life elsewhere exists. On November 16, 1974, the Arecibo message was sent into space to celebrate the remodeling of the Arecibo radio telescope. The message contained in binary the numbers 1 to 10, the atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus, the formulas of sugars and nucleotides in DNA, and a double helix structure, a crude figure of a human being, along with the average height of a man, along with the human population of Earth. It also contained a graphic of the solar system and showed where the message originated, Earth. Finally, it contained a graphic of the Arecibo radio telescope, along with the dimensions of it. It will reach its destination in 25,000 years. The message was aimed at globular star cluster M13. Coincidentally, M13 will not be in the same location 25,000 years from the future. So the Arecibo message was more of a ceremonial demonstration of technology than a real attempt at communication. Have other civilizations attempted to communicate in this way? The Search for Extraterrestrial Intelligence, or SETI, is the name for projects that attempt to search for intelligent extraterrestrial life. The most common would be the monitoring of electromagnetic radiation for signs of another transmitting civilization. SETI uses radio telescopes with large radio antennas to search the sky. The assumption is that intelligent extraterrestrial signals would be easy to identify due to a repetitive nature and narrow bandwidths. An analogy for this could be a lighthouse in space, waiting for detection. Due to the vastness of the universe and the galaxy, this may be the only feasible way to communicate with extraterrestrials, if there are any. Just because a planet is within the so-called habitable zone of a star much like Earth and contains water and oxygen, does that mean it will ever develop life? These are the kinds of questions that are nearly impossible to answer. It is what makes the Drake equation only a guess and nothing more. There is no evidence that extraterrestrials exist. We do not know if life is common in the universe or in the galaxy. We can only speculate. Life could come in all forms beyond our wildest imagination, or there could be nothing out there at all. Information for this video was found at SETI.org, usefulcharts.com, and waitbutwhy.com.